Okay, here, quick, important. It could be that there are different kind of versions in the field, and I'm not 100% sure which one are mounted in Japan and which inlet they use exactly. Could be opposite as well. Okay, quick on the exhaust gas heat exchanger. The exhaust gas heat exchanger, we're running here into the exhaust gas heat exchanger with the exhaust gas. So in case we have a problem on the exhaust gas or on the engine, and we have a bad combustion, a lot of smoke, or we burn H2S, or we burn oil, or we have a damage on the turbocharger and the exit oil goes into the exhaust gas, that will run through all these pipes, and maybe they can get problems in the pipes, that the pipes get clogged, so that we get ruse, oil, old oil, burnt oil, that we get different other components into the pipe, or condensate as well. So, and then it could happen that that pipe where actually the exhaust gas runs through get blocked or more and more blocked, and that forces a higher back pressure to the engine. So we will do a separate video on exactly on the exhaust gas and the maintenance on that, but only keep that in mind. The exhaust gas is not always clean. Depends on what we burn and how clean the gas is, or if we have a damage on the engine, could happen that we get oil or something other into the exhaust gas, what can block up the exhaust gas heat exchanger. So this is the temperature limiter what we talked already. This one is as well one in the HTU. The other one, the second one, is in the exhaust gas heat exchanger. Okay, we was talking about already, so only that you know, both are used serial, and one is in the HTU hydraulic separator, the second one is in the exhaust gas heat exchanger tank on top. Okay. Okay. We have here the heat transfer unit bypass valve, filter, dirt trap. That's the main valve, or the main filter string. That should be cleaned regularly with the maintenance. So we have to open here. Please always, there's a very thin rubber, it's not a rubber, gasket in the cover here. Always replace it completely. Don't use the old one again, otherwise it starts leaking. So if the first filter here get clogged during operation, the system will recognize that and will automatically open that valve so that the water flow can bypass the main line, and the CHP can still operate with this arrow, but now we have to go in action and have to clean the filter as soon as possible. So before we get any problems with the CHP or an arrow to stop the CHP. So we have here the HTU with the filter strings here, main and bypass. First, if you'd like to clean the main filter, because that get first blocked, then it switch automatically to the bypass and the valve opener to the bypass. First, here we have a switch on a cabinet board on the HTU. Switch the control on off so that the control here, the motor, will stay as it is. So, and then cover all stuff underneath. So we have here the emergency cooler, actuator, motors, and the bypass motors, so that they're not getting completely wet. If you open the filter, water will come out. So only make sure to protect them. And after cleaning the filter, make sure that you put it in back properly before you're closing it. Replace the gasket as mentioned already, and after cleaning you can switch back to auto mode, and the motor should be closing that valve, and automatically the water flow will go back to the first dirt trap. Yeah, so our cooling water system is designed that we have different opportunities to adjust the return flow temperature, that's that one, to adjust that on the client's need. Usually the best is if we can run it as cool as possible, so we keep the engine always on a stable low temperature side, but we have three opinions here to adjust the target of the return flow temperature to the engine. This target this target temperature have impact on the forward flow, a little bit deeper, on the forward flow temperature to the client. So that means if we set up higher return flow temperature, if we set up 5 degrees higher return flow temperature here, we will get approximately 5 degrees higher forward flow temperature. So if the client needs a higher forward flow temperature, we can adjust that between 70, 75 and 80 degrees Celsius. This is always our target. The whole cooling cycle will control and like to keep that temperature to the engine stable. A stable engine temperature means less wear of the engine, less problems with temperature fluctuations. So that's a very strong target where we keep an eye on it. So the control goes on that target what we adjust. If the temperature from the client is too high, then we will operate automatically through the emergency cooler to keep the temperature low. If the temperature used or the heat used of the client is high, then the return flow temperature from the client will be very low. And again, to keep that stable, we will run the bypass. So if it's cold, we need to open the bypass, so circulate a little bit hot water through the bypass. If the temperature from the client is hot, then we don't need the bypass anymore. If it's hot, we have to circulate through the emergency cooler before we reach the engine again. Here on that flow diagram, we can see at the moment the bypass is almost closed, or it's closed, and the emergency cooler is open. We see the temperature from the client is very high. The target is 70 degrees, is 77 degrees from the client, and our target of the engine is 70. We like to keep the 70. That means here the control at the moment is running through the emergency cooler. Valve is 99%, so 100% open, and the speed of the fan already went up to 35% instead of standard minimum of 20%. So that means we are cooling the whole hot water with the emergency cooler and blow the heat into the air to keep our return flow stable. Yeah, our emergency cooler. So the emergency cooler cycle, as I mentioned already, is that area, and the function is to keep the temperature of the return flow of the engine stable. So in case the client don't need heat, we have to cool down. First function is we control the temperature flow through the cycle with the freeway valve. So the control starts if the bypass valve here, the bypass valve reach the 0%. After we reach the 0%, the cooling function must get in place that we keep the temperature stable. So the first will be we open here our freeway valve, before I forget, when we start the CHP, immediately the emergency cooler fan will go on a minimum speed, as the same as the charge air cooler fan. After start CHP, minimum speed of the fans. The first step is that the freeway valve controls the return flow of the CHP, of the engine. If we reach the 100% or 99% here, then we start to increase. So if we reach the opening here, then we start to increase the speed of the emergency cooler. That's that one. So we have the emergency cooler here. Underneath the emergency cooler, we have mounted a temperature sensor. It's a PT1000 sensor, measure the ambient temperature underneath the emergency cooler. To measure the outside temperature, to have an option to adjust the speed control, or the speed control of the fans. We'll get soon to it. I like to, we have here on the emergency cooler 2 air release valves. I need to mention very quickly. In case there's air in the cycle, here we can get the air out of the release valves. So the emergency cooler system measures the ambient temperature. The ambient temperature, if we have a very cold ambient temperature, we have to adjust the PID control settings. So that means the PID is a controller what controls the speed of the fan. So we can adjust the settings of that. If we measure a cold outside temperature, the PID controller must, the reaction of the PID controller must be slower than if the temperature outside is hot, then the PID controller speed must be faster. So the reaction must be faster. The faster means that the speed of the fan gets controlled faster, and slower means that the speed of the fan gets controlled slower. If the temperature is lower, so smaller change on the speed of the fan will have the same impact as we have a fast reaction with hot temperature outside on the fan speed. So in case I control the speed too fast, if this is cold outside, I will get too fast temperature fluctuations, and it starts to swing. That's why they have a linear PID settings change between cold and hot temperature. We can go into that deeper on another video. So, and then the last point, actually, it will be nice if we can measure the water quality, to analyze the water quality, so that we can take samples of the different cycles once a year, for example, and analyze what is the content of the water, what is the quality of the water. I'm not sure if it's possible for you that you have somewhere close to you a company where we can analyze the water samples. Let me know if you have some options. I will provide you the list of measurement, what we should measure and what are the limitations, and so that we can understand the quality of the water, and if this water is in the limitation, that we ensure that we're not forcing any damages with a bad water quality. So, what did we learn today? Getting late. Okay, we know now all the different components of the different cooling cycle of the charge air cooling system, the safety module, the engine, the heat transfer unit. We know how to adjust the water flow through the different cycles. Very important to monitor, to test, and in case it's not on the target, we have to adjust it. We know now how important the extension tank is and how to test or measure the pressure and the function of the expansion tank. and we understand the function of the different equipment components around the whole system, the different sensors, what is in place. Yeah, coming soon. Next thing is to go deeper in detail what is with the panel PC, controller board cabinet, and as well that we go deeper in function of the synchronization cabinet and power cabinet, where the synchronization get in place. This visualization and the sensors, very deep, detailed function and operation of the engine controller unit, engine injection system, the injection replacement and conveyor system in details, and service maintenance equipment, oil system of the engine, cooling system, and so on. And what will be very important as well, what we do videos where we go through potential areas or potential equipment, what we have to make keep an eye on it to provide the best operation lifespan for all the different equipments. Okay, so I think we are through for today. Thank you so much for watching. I really appreciate your time to spend what you spent on my videos, and I hope you had learned a lot today. And yeah, give me some feedback on the video so that we know, okay, what we have to focus on. And yeah, then thank you so much for your time. Arigato, and see you on the next video. Have a great day. Thank you.